everyone, welcome to Math Quiz. In this video, let me see an example under odd and even functions in Fourier series. For that, let me take an example. Expand f of x equal to x squared as a Fourier series in a closed interval pi minus pi comma pi and deduce the following three series from that. So, before we move on to the problem, let me have a short look over the formulas that we are going to use. So, very first one that we are going to see is integral uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. It is commonly known as Bernoulli's formula. We make use of this formula whenever both u and v are functions of x. If whenever we see the both u and v are functions of x are in product. If so, to evaluate that integral, we make use of this formula to get the result. Here, u dash is nothing but du by dx. That is, you have to differentiate u with respect to x one side. U double dash is d square u by dx square. That is, you have to differentiate u with respect to x twice, etc. So, we have to say u dash, u double dash, u triple dash, etc. are derivatives of, successive derivatives of u. Whereas v1, v2 and v3 are successive integrals of v. v1 is nothing but integral v dx. Whereas v2 is integral v1 dx. Or you can write, you have to integrate v twice with respect to x. So, no need to do this. Already we calculate v1. So, you have to integrate that once with respect to x. That's enough. That is your v2. Next, v3 is integrate v thrice with respect to x. So, for that already we have to integrate that twice. So, I have to integrate once again with respect to x means that is your v3. So, integral v2 is dx is nothing but your v3 etc. So, u dash, u double dash, u triple dash are successive derivatives of u, whereas v1, v2, v3 are successive integrals of v. Next one, the basic formulas of integration and differentiation, as you know already. Integral x bar n dx is equal to x bar n plus 1 divided by n plus 1 and d by dx of x bar n is equal to, while differentiating, n x bar n minus 1. Okay. So, integral sin n x dx is equal to minus cos nx divided by n and integral cos nx dx is equal to sin nx divided by n. Whereas the value of cos 0 is 1 and cos n pi is minus 1 whole power n. Whereas sin 0 value is 0 and sin n pi value is 0. Here if n is an integer, we most probably discuss about the values of n as integer. So, sin n pi we already directly we have to take as 0. Now, let me move into the problem section. Expand this function f of x equal to x squared as a Fourier series in minus pi comma, that is a closed interval minus pi comma pi. So, first we have to find the Fourier series representation of the given function f of x is equal to x squared, that is given in the interval closed interval minus pi comma pi. Whenever you are going to write the function, you have to write the function along with the interval. That is very must. Okay. So, as I told you already, the case of odd and even functions arise only for the two intervals minus pi comma pi or minus l comma l, and the case of odd and even doesn't arise for the two intervals like 0 comma 2l and 0 comma 2 pi. So, in the case of odd and even arise only for the two intervals of minus pi comma pi and minus l comma l. So, for that, look at the interval here. This is of minus pi comma pi. So, definitely we have to check whether the given function is of odd or even. Based on that, we have this Fourier series representation. If it is odd, we have a Fourier series representation, separate Fourier series representation. If it is even, we have separate formula for finding the Fourier series of the given function. So, for that, what we do as usual, you have to replace the given. In the given function, you have to replace x by minus x. If you replace x by minus x, what happens? That is minus x squared, that is x squared. So, x squared nothing but f of x. So, f of what you get here, f of minus x is equal to f of x. What it means, whenever f of minus x is equal to f of x, immediately we can say that f of x is an even function in the interval minus pi comma pi, isn't it? If it is an even function, immediately you can write the value of bn is 0. If the value of bn is 0, then let the required Fourier series be of the form f of x equal to, the Fourier series consists of only a naught and a n alone. So, f of x equal to a naught divided by 2 plus sigma n varies from 1 to infinity a n cos n x, where a naught is calculated by make use of the formula 2 by pi integral 0 to pi f of x dx, and a n is calculated by make use of the formula 2 by pi integral 0 to pi f of x cos n x dx. So whenever the function is an even function, bn becomes 0, so we don't have bn term here. So you take this as equation number 1, and this one as equation number 2, and this one as equation number 3. So let me first calculate the values of a naught and a n. So after calculating the values of a naught and a n, substitute in equation 1 gives you the Fourier series representation of the given function f of x equal to x square. So first we have to calculate from equation 2. From equation 2, we calculate the value of a naught. So a naught is equal to 2 by pi integral 0 to pi f of x dx. You know what is the given function f of x? Just replace f of x by x square dx. You know the integral of x square dx, isn't it? 2 by pi, we make use of the formula. That is x power 2 plus 1, x power n plus 1 divided by n plus 1, isn't it? That is twice x cube 2 times 2 by pi of x cube divided by 3 with the limit from 0 to pi. Here itself we got right. 0 to pi. So that is equal to 2 by pi. Just replace upper limit of x by, that is x by the upper limit, that is pi cube by 3. Next lower limit 0, 0 cube by 3. So upper limit minus lower limit. So after substituting the limits, this term becomes 0, isn't it? Already it has numerator 0. So that is equal to 2 pi cube divided by 3 pi. So one of the pi being cancelled, so you get only 2 pi square divided by 3. This is the value of your a naught. So a naught is equal to 2 pi square divided by 3. So we calculate the value of a naught. Next we calculate the value of a n. For that we make use of equation 3. From equation 3, what is your a n? A n is equal to 2 by pi integral 0 to pi f of x cos nx dx. So replace the value of f of x by x square now. So 2 by pi integral 0 to pi f of x is x square cos nx dx. This is a product of two functions. So we make use of the Bernoulli's formula to evaluate this integral. As I told you already, integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3. We have to stop up to this because this derivative is of power 2. So we don't have the next term. So let me see how this happened. So we make use of the formula. So I am going to take the first function as u, the second one as v. So now u is x square. What is your u dash? U dash is 2x, nx power n minus 1. 2x power 2 minus 1, that is 1. So no need to write it. And u double dash is 2 is a constant. Integrating x you get only 1. So 2 product 1, that is 2 itself. What is your u triple dash? While differentiating a constant you get 0. So that's why we doesn't have the next term here. Okay. So we have to stop up to u double dash. So next we calculate v1, v2 and v3. So your v is cos nx and v1 is nothing but integral v dx. That is integrate cos nx once. So integral cos nx is nothing but sin nx divided by n. Next again you have to integrate this. That is v2 is nothing but integral sin nx divided by n dx. So here 1 by n is a constant, so keep it as a constant. So integrating sin nx you get minus cos nx divided by n. Already you have 1 n in the denominator, so that is n square. Next v3 is nothing but integral minus cos nx divided by n square. Here minus 1 by n square is a constant, so keep it as it is. So integrating cos nx you get sin nx divided by n. Sin nx divided by n, already you have n square in the denominator, so that becomes n cube. So let me substitute. Now we are going to evaluate this integral. For that we make use of this formula, that is u v1 minus u dash v2 plus u double dash v3. So if you are well versed about this formula, no need to write like this. Okay. So you can directly substitute it. Okay. Next, your a n is equal to 2 by pi u v1. What is your u? X square. v1 is nothing but sin nx divided by n minus u dash is 2x. v2 is nothing but minus cos nx divided by n square plus u double dash is nothing but 2 and v3 is minus sin nx divided by n cube with the limit from 0 to pi. So now So minus and minus here positive, plus and minus becomes negative. So let me first simplify the symbol so that it will be easy for us to substitute the limits. Okay, so first term we have no problem. So x squared sin nx divided by n. So write it as it is. Here minus and minus becomes plus. So plus 2x cos nx divided by n square. Here plus minus becomes minus twice sin nx divided by n cube with the limit from here 0 to pi. So let me first mark the x term here. So first let me substitute upper limit and then lower limit. So 2 by pi. So the bracket is very important here. So whole bracket is represented using this type of bracket, and upper limit, this bracket for upper limit, minus lower limit. So how much space you need, based on that you put a bracket. Okay, so the bracket is very much, because upper limit here we use minus lower limit. Okay, now let me first substitute the limits. So upper limit is pi. So if you replace sin n pi, you know the value of sin n pi. What is the value of sin n pi? Sin n pi is 0. Since the value of sin n pi is 0 means the entire term becomes 0, the first term becomes 0. Coming to the second term, look at the cosine term first. Cos n pi. You know the value of cos n pi. What is the value of cos n pi? That is minus 1 whole power n. That is 2. Here itself you have x, that is replaced by pi. Minus 1 whole power n divided by n square, minus twice sin n pi. Sin n pi value is 0. Minus, coming to the lower limit. Lower limit we have to replace the value of x by 0. If we replace the value of x by 0, what happens? 0 into anything 0. Sin 0 is also 0. So here itself you have x. So first term becomes 0. Plus, coming to the second term, cos 0 value is 1. Whereas that is multiplied here with 0. So second term also 0. Minus, coming to the third term. So sin 0. Sin 0 value is 0. So there is no value for the lower limits here. So 2 by pi. 2 pi minus 1 whole power n divided by n square. Simplifying this, you get pi and pi being cancelled. So you get 4 times minus 1 whole power n divided by n square. So the value of an we have calculated as 4 times minus 1 whole power n divided by n square. So we have calculated both the values of a0 and an. So let me substitute in equation 1. From equation 1, so what is equation 1? F of x, general Fourier series, that is a0 by 2 plus sigma n varies from 1 to infinity an cos nx. You know both the values of a0 and an. So substitute both the values of a0 and an. A0 value is 2 pi square divided by 3 whole divided by 2 plus sigma n varies from 1 to infinity. Your an is 4 times minus 1 whole power n divided by n square cos nx. So 2 and 2 being cancelled here. So that is pi squared by 3 plus here 4 is a constant. So take it outside of the summation. So 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos nx. This is your f of x. So this is the Fourier series representation of the function f of x equal to x square defined in the closed interval minus pi comma pi. So we have find out the Fourier series representation of the given function f of x equal to x square in minus pi comma pi. After that we move on to the deduction part. So we have deduced 3 types of series from this. So let me show you the question to you once again. This was the given question. Okay, so you have to deduce 3 different types of series from this. So what is the given? So what is the series we have deduced? That is, I have tried it once again. So we have derived the series f of x is equal to pi square divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos nx. This is what the series we have deduced for the function we have derived for the function f of x equal to x square. So from this series we have to deduce this 3 types of series. So look at here, we have only cosine series. As I told you already, cosine series in most of the cases, okay? In most of the cases, cosine series is obtained by putting x equal to 0 or x equal to pi. So you have to take the first and second possibility as x equal to 0 and x equal to pi. Okay, keep that in mind. So this is not the general rule, but in most of the cases, cosine series is obtained by putting x equal to 0 and x equal to pi gives you the required series. Okay, this is what we are going to do now. So for that, what I am going to do here is I am just substitute x equal to pi first, and let me check which series I am going to get, okay, from that. Now put, So here I have tried once again the series. So f of x equal to, what is the general Fourier series? We have just now derived pi squared by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos nx. Okay. So from this series, first what I am going to do is put x equal to pi. So I am just write the given function. Given function is f of x equal to x square, that is defined in the interval closed interval minus pi comma pi. What is the meaning of that? That is, closed interval means what is the meaning of that function defined in the closed interval means x is continuous at all points including minus pi and plus pi. Okay. So the meaning of this interval is x is continuous at all points including minus pi and pi. That is the meaning. So plus pi is approximately here. Here both minus pi and plus pi both are continuous points. Okay. Since it is a closed interval. So x equal to pi is a continuous point. If it is a continuous point, what we have to do? So as we already discussed under convergence of Fourier series, if it is a continuous point, what we do? We have to substitute the value directly. Okay. So the link is given in the description box. For more details, you refer the link. Okay. So the point is continuous. What we do? You have to substitute the value directly to get the value of the function at that point. Okay. That is what we are going to follow. So x equal to pi is a continuous point. So now what I am going to do, just replace the value of x by pi. So in these two places we have x. Now f of x at x equal to pi, or you may write this as f of pi, whatever that may be, both are equivalent. Okay, that is equal to pi square divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos n pi. You know the value of cos n pi, isn't it? Here I replace x by pi. So f of x at x equal to pi. F of x at x equal to pi means f of x is x square, isn't it? Here f of x is x square. Just replace x by pi, you get pi square. So if it is a continuous function, we have to directly replace the value of the function by the point. Okay. So x square, so just replace x by pi, you get pi square, that is equal to pi square divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square, and value of cos n pi is minus 1 whole power n. That is pi square, you just take this pi square by 3 to other side. So pi square minus pi square divided by 3, that is equal to 4 times sigma n varies from 1 to infinity. Look at here, minus 1 whole power n and minus a base same. So you have to add power. So minus 1 whole power 2n. Minus 1 whole power 2n is nothing but, that is plus 1, isn't it? Minus 1 whole power 2n. Minus 1 whole power 2n is nothing but plus 1. That is I have to write this as minus 1 whole square power n. Minus 1 square 1 power n is nothing but 1 itself. So if you are very well versed about this concept, means you have to directly replace this value by 1. So in your next step, let me take an LCM here. So 3 is an LCM we are going to take. So 3 pi square minus pi square divided by 3, that is equal to, so we take an LCM this side, that is equal to 4 times sigma n varies from 1 to infinity 1 by n square, isn't it? The value of this one is plus 1, isn't it? So that is equal to 4 times sigma n varies from 1 to infinity 1 divided by n square. So 3 pi square minus pi square is nothing but 2 pi square divided by 3, that is equal to 4 times sigma n varies from 1 to infinity 1 divided by n square. So keep this series along this side. So I have to write this series to the left. Okay. So for my convenience. So that is equal to, take this 4 to other side. If you take this 4 to other side, what happened? 2 pi square divided by 3 4s are 12, isn't it? That is pi square by 6. So expand the series by substituting n is equal to 1, 2, 3, etc. you get. So first substituting n equal to 1, 1 by 1 square, n is equal to 2, you get 1 by 2 square, and n is equal to 3, you get 1 by 3 square plus etc. That is equal to pi square divided by 6. You take this equation number A. So we have obtained the first series in the given question, isn't it? So we have obtained the first series, that is 1 by 1 square plus 1 by 2 square plus 1 by 3 square equal to pi square by 6. So the point x equal to pi gives you the first series, isn't it? The point x equal to pi gives you the first series in the direction part. What is the next point we are going to take? X equal to pi. If you substitute x equal to pi, then definitely you get the second series, that is the same series, here you have alternatively plus minus, that is equal to pi squared by 12. Okay, so that is what we are going to see. So the second deduction part, what I am going to, first I am write the general Fourier series, that is for this function. So f of x is equal to pi squared divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos nx. This is what the Fourier series representation of the given function f of x equal to x squared, isn't it? So from this series we have deduced the first series. Now we move on to the second. So to get the second series, now which point I am going to take, which x equal to 0. As I told you already, f of x equal to x squared is defined in the closed interval minus pi comma pi, which means x is continuous at all points including minus pi and plus pi, and 0 is approximately here, that is also continuous point, isn't it? If x is, so x equal to 0 is a, which is a continuous point, If it is a continuous point, as I told you already, you have to directly replace the value of the function in terms of x by 0. That is f of, here in these two places you have x, just replace x by 0, f of 0, or you can write f of x at x equal to 0, both are equivalent. Okay, so pi squared by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square cos 0, isn't it? Cos n 0, that is cosine 0. So f of 0 is nothing but, since 0 is a continuous point, you can immediately replace the value of x by 0 directly. So f of 0 is nothing but 0 square. 0 square is 0 itself, isn't it? That is equal to pi square divided by 3 plus 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square, cosine 0 value is 1. So that is equal to, you just take this value to other side, what happens? Minus pi square divided by 3, that is equal to 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square. So what I am going to do next is, you just expand the series. Okay, so that is equal to, and just write the series once again here, 4 times sigma n varies from 1 to infinity minus 1 whole power n divided by n square, that is equal to minus pi square divided by 3. Okay, so what I am going to do now, you just expand this series and take this 4, now take this 4 to other side. So if so, what happens? Sigma n varies from 1 to infinity minus 1 whole power n divided by n square is equal to minus pi square divided by 12. Expand this series first by putting n equal to 1, 2, 3, etc. If you replace n by 1, minus 1 whole power 1 by 1 square. If you replace n by 2, minus 1 whole square divided by 2 square. If you replace n by 3, minus 1 whole cube divided by 3 square, plus etc. That is equal to minus pi square divided by 12. So minus 1 whole power n is minus 1 by 1 square here, plus minus 1 whole square is plus 1 divided by 2 square, plus minus 1 by minus 1 whole cube, that is odd term. So you have minus 1 by 3 square plus etc. That is equal to minus pi square divided by 12. So here you have minus, or we can take, you just multiply minus on both sides. Okay, what you get? So here first term of minus becomes plus, 1 by 1 square minus 1 by 2 square, plus become minus, next minus become plus, plus become minus, etc. That is equal to, here minus becomes plus, that is pi square by 12. Okay, so this is what the second series we have obtained. Now let me move on to the third part. In the third part, what we are going to deduce? In the third part, we have to deduce the series of the form 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to pi square divided by 8. So you have to take this as equation number B, the second one as B. Okay, so we have to deduce this series. So what we are going to do is, what is from A? In the first one, what we have deduced? We have deduced the first series as 1 by 1 square, that is from A. Okay, from A, that is first series we have deduced by putting x equal to pi is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus etc. That is equal to pi square by 6. From equation B, that is just now we have deduced this series, isn't it? So 1 by 1 square minus 1 by 2 square, isn't it? 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. That is equal to pi square divided by 12. What I am going to do here is, I just add these two series. Okay? From the two series which I am going to deduce just now, I am just adding these two series and try to get the third one. Okay? So adding these two series gives you what? So add A plus B. That is a series deduced first and second. So adding these two series, what you get? First term being cancelled. First term is not cancelled. 1 by 1 square. That is, you get twice 1 by 1 square. Isn't it? Both are positive term. Second term being cancelled because plus minus. So second term is cancelled. So you don't have the second term. That is, you put 0. Okay, for your understanding, I just read it. Third term, what you get? Here plus the same term. So 2 times, I just take 2 come and take it outside. 1 by 3 square plus. What is your next term? If you are having the next term, what is your next term? Plus 1 by 4 square is your next term. Here you have minus 1 by 4 square is the next term. So this term being cancelled. 0. And then next plus. What is the next term of this series? Plus 1 by 5 square plus etc. Here you have plus 1 by 5 square. Because alternatively positive, negative, etc. So what you get? Plus 2 times you have 1 by 5 square. 2 is common and take it outside plus etc. Okay, you just write first 3 terms of the series. That's enough. Okay, that is equal to pi square divided by 6 plus pi square divided by 12. You just add both left hand side and right hand side. So in the right hand side you have pi square by 6 and pi square divided by 12. So adding this we get, that is twice 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to, here if you take an LCM as, what is an LCM? You take 6 and 2. So suppose if you are getting confused, take an LCM like this. This is what basic procedure we have to follow. Okay, isn't it? 6 means 1, 2, 6 are 12. So multiply this 12. 12 is an LCM. This is a basic concept we follow. Suppose if you are confused with by taking LCM, you make use of this process. So 12 is an LCM. So 12 is an LCM means what I am going to do? I am going to multiply both numerator and denominator of this term by 2 times because 6 2s are 12. So by doing so, you get the denominator as 12. So 2 pi square plus pi square, isn't it? So now twice 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to, here you have 2 pi square plus pi square is 3 pi square divided by 12. That is 3 pi square divided by 12. That is nothing but 4 3s are 12, isn't it? So 2 times 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to pi square divided by 4. What I am going to do? You just take this term to other side, keep the series this side. That is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus etc. That is equal to pi square divided by 4 2s are 8. So this is what the third series we are going to deduce. Okay. So by adding the previous 2 series, you get the third series. Up to this, hope you got a clear idea about how to find the Fourier series representation of the given function f of x equal to x square given in the defined in the closed interval minus pi comma pi. Thanks for watching. See you all again in my next video.